Welcome. In this video we will take a look at arithmetic series. So we've looked at arithmetic sequences in previous videos, so in this case we're going to be talking about taking the sum of the terms in an arithmetic sequence. Again, a series is just the sum of the terms in a sequence, and so if we're talking about an arithmetic series, we're talking about summing the terms in an arithmetic sequence. So to understand how we would find such a sum, let's start with an arithmetic sequence. And we'll do just a very basic one here. 1, 2, 3, 4, so on and so on. And we'll stop this one at 100. And this is arithmetic, of course. The common difference, hopefully we can tell here, is just 1. We're just increasing the terms by 1 every time. But what we want to do now is to find the sum of these terms. So what we're taking is 1 plus 2 plus 3 plus 4, and so on, up to 100. We'll try to add these numbers one at a time. Not that it would be very difficult, but it would be extremely time consuming. So we want a faster way of computing this sum without having to add the numbers one at a time. And so we can do that if we take the exact same series and write it backwards. So starting at 100 and then going to 99, 98, and so on until we get all the way down to 1. And what I'm going to do is I'm going to take these two different versions of the sum and I'm going to add them together. So we're going to take 1 plus 100, that would be 101. Then we would have 2 plus 99, that's also 101. 3 plus 98 is also 101, and so on. Each of these sums will end up being 101. Well, computing this sum actually wouldn't be too bad, because we have 101 every time, and we know that adding these values together, going from 1 to 100, that there would be 100 of these terms. So the sum in this case, we would have 100 times 101. And of course, I could multiply that out pretty easily. This would just give me 101 followed by 2 more zeros, so we'd be looking at 10,100. Now that's not the actual sum that I'm looking for. What I've done here is I've added the sum to itself. So if I wanted to find the sum of the original series, in other words, if I'm looking at the actual sum of the terms here, then I would want to take this result, the 10,100, and I would need to divide it by 2. Again, the 10,100 is doubling up the original series, so to find the original series, we just have to divide this back by 2. Anyway, if we do that, we end up with a final result here of 5,050. So what that's telling us is that 1 plus 2 plus 3 plus 4, etc., all the way up to 100, ends up being 5,050. Well, any arithmetic sum is going to work the same way that this example did here, so we want to make sure we understand what exactly was happening. So when we added the terms together to get the 101 each time, really we could look at that as just adding the first and last term together. If we do that, that gives us the total of 101 that we saw in this example. So you could do the second term and the second to last term, obviously, but we can get the same result just by looking at the first and last term. And that same result will work for any arithmetic series. So that's what we'll start with, is adding the first and last terms. But then we took that total and we multiplied it by the number of terms that we had in the series. So in the example we were just looking at, we took the 101 and multiplied it by 100, because there were 100 terms in the series. But then we took that result and divided it by 2. And so what I've just explained there is exactly what we'll do for arithmetic series every time. So let's go ahead and write this out in the form of an equation. So for arithmetic series, assuming that we know it's arithmetic, so assuming that we know that the terms form an arithmetic sequence, then when we're taking the sum, let's say as I goes from 1 to n of a sub I, we take the total number of terms that we have, which is n, and we multiply that by the sum of the first and last terms. So the first and last terms would be a sub 1 and a sub n, so we have to add those together. But then that doubles up the original sum, so to get the original sum, we just have to divide it by 2. So if you go back and look at the steps that we showed in the previous example, that's exactly what we had done here, is following this formula. but it turns out that this formula will work for every arithmetic series, not just that specific example. So you want to make sure you know this formula here. This is what we'll use every time we're dealing with an arithmetic series. So let's try this on another example here. What if I wanted to take the sum, let's say as j goes from 1 to 20, of 2j minus 3? Well, first of all, notice here that we know that we're talking about an arithmetic series because the expression 2j minus 3 is linear. So we talked before about how arithmetic sequences, their formulas are always linear expressions, and that's exactly what we have here. In fact, the coefficient of our variable, the coefficient of j, is 2, which tells us that the common difference of the terms would be 2. In fact, if we want to, we could go ahead and list some of the terms in this series here. So when I plug in 1 for j, I would have 2 minus 3, which of course would be negative 1. When I plug in 2 for j, I would have 4 minus 3, which would be 1. If I plug in 3 for j, I have 6 minus 3, which would be 3. And so notice that the terms are increasing by 2 every time, just like we said. Now if I keep on going here, the last number that I plug in for j is 20. So if I plug that in, I'll have 40 minus 3, which is 37. So I'm not going to write out every single term here, but we don't need to. But oftentimes it is helpful to actually list some of the terms just to kind of help you get your bearings and understand what it is that we're actually working with. So it is a good idea to actually list the terms here. At any rate, how would we find the sum? Well, following our formula here, n represents the total number of terms that we have in the series. So in this case, we have 20 terms. And then I multiply this by the sum of the first and last terms in the series. So the first term we can see is negative 1. The last term is 37. So I simply have to add those two numbers together. But then we take that result and we divide the whole thing by 2. So simplifying this, we'll have 20 times 36 over 2. And to make things easier on myself, I'll reduce the 2 with the 20, so that will become 10. So we're simply taking 10 times 36, which of course we know is 360. So this gives us a very fast way of adding all the terms in this series. But again, this only works if we know that the series is arithmetic, so that's very important. This formula will not work with any series. It has to be an arithmetic series to work. But that gives us the total of all of the terms in this series. So let's try some other examples here. What if I were taking the sum, this time let's say as k goes from 0 to 199, negative 4k plus 2. And so again, I often recommend writing out the first few terms, at least the first and last term, since we'll be using those in the formula. So in this case, our first term, we'll be plugging in k equals 0. And if I do that, I'll end up with 2. Then the next term, we would plug in 1. And if I do that, I will end up with negative 2. So I'll just write this as minus 2 here. Plugging in 2, we would have negative 8 plus 2, so it would be negative 6, and so on and so on. And of course, notice here that the terms are decreasing by 4, and we would know that anyway because the coefficient of k is negative 4, and that gives us the common difference of the terms. Anyway, if we find the 199th term, plugging 199 in for k, what we'll get here is negative 794. So that will be our last term when we plug in the 199. Now let's actually find the sum here. So again, I don't recommend doing this by adding the terms one at a time. Notice here that the number of terms that we have is 200. Why is that? Well, we're starting at k equals 0 and going to 199. So if you think about it, if we were going from 1 to 199, that of course would be 199 terms. But starting at k equals 0, that adds an extra term. So we're actually looking at 200 terms here altogether. But just as before, we want to add the first and last terms of the series. So the first term is 2, and we can see that the last term is 794. So we're actually subtracting 794 this time. But we still need to divide that by 2. And so simplifying here, we'll have 200 times, this will be negative 792. That's still divided by 2. And so I'll simplify by dividing the 2 with the 200, make this 100, So we just have 100 times 700, or negative 792. And so the result here, we just take negative 792, and since we're multiplying by 100, you simply have to tack on 2 more zeros. So our final result here is negative 79,200. So for some of the problems in the homework, you may want to do the computations on a calculator. Exam questions will be a bit more like these examples here, where you end up multiplying by some multiple of 10 or by 100, just to make the arithmetic a little bit easier. But sometimes the problems, the arithmetic may be a bit more challenging, so feel free to use a calculator if you need to. Anyway, let's take a look at another type of example here where we're not using the sigma notation. So what if I said to find the sum, let's say, of the first 20 terms of the series, let's say 2 plus 5 plus 8 plus 11, and so on and so on. Well, what we want to do here is basically the same thing as before. It's really the same sort of problem, they just aren't writing it in sigma notation. They're just giving us the actual terms here. Well, we can see that the first term, of course, is 2. But if we're going to calculate the sum here using the formula that we've been working with, then we're going to need to know what the 20th term is. And so what that means is that we're going to need to find an expression for a sub n first. So looking at the actual terms, thinking of them as a sequence, this is arithmetic, so we can write it using the formula for arithmetic sequences that we saw earlier, which was a sub 1 plus n minus 1 times d. In this case, if I want to find the 20th term, a sub 20, that's going to be a sub 1, which we can see is 2, plus 20 minus 1 times the common difference, which hopefully is easy enough to see, is 3. And so finding the 20th term, what we'll have here is 2 plus 19 times 3, which will give us 59. So now to calculate the actual sum, again, just going back to our formula, n times a sub 1 plus a sub n over 2. Well, we're trying to find the sum of the first 20 terms, so our n value will be 20 in this case. And then we'll have a sub 1, which we pointed out already is 2. A sub n, that refers to a sub 20, that's the last term, which we just calculated is 59. And then we would want to divide that by 2 as well. And so simplifying here, we'll have 20 times 61 over 2. Again, we can reduce the 2 with the 20, make that a 10. So we're simply taking 10 times 61, which of course is just 610. So that would be the sum of the first 20 terms of this series. And so again, this example really is just like the previous ones. The only difference is that it's not being written expressly using the sigma notation, but the idea is the same. So in this case, we had to find a formula for the terms in the sequence itself so that we could find what the 20th term was. And then finding the sum of those terms is again just relying on our formula for arithmetic series.